Hello. Good afternoon. And for those of you watching at home, hi, Mom. My name's Kevin Poorman. I'm a developer evangelist at Salesforce. I point out the at Salesforce part primarily because I have to make you look at this. If you've never seen this before, this is our forward-looking statement slide. It's super exciting to read. I'm going to give you all a second to read through it all. Since it's so short, I'm sure you're done now. Basically, it reminds us of two things. One, it reminds me not to make any forward-looking statements, and two, it reminds you to make your purchasing decisions based off of things that are already publicly GA and available. Does that make sense? I like to do interactive presentations, so I'll ask you questions, you answer, you ask questions, I answer. If you don't answer any of my questions, then we'll have awkward pauses. Okay? Great. So, who am I? I'm Kevin Poorman. I am a developer evangelist. That means I do cool things, and then I get to get up and tell people about them. So today we're going to talk about Apex testing, and if that sounds like a cool thing, then you're right on, right? If you think I'm deceiving you, then I can understand why, but we're going to do some cool stuff in our Apex testing. Come on in today. And you can email me at kpoorman@salesforce.com, or you can tweet me at Twitter. Since I get a notification in my pocket every time my phone goes off with a new tweet, you're more likely to get an immediate response out of me with Twitter rather than email. All right? Especially since right now it is only 10 in the morning where I'm from. All right? So I like to run a competition. If you tweet a funny picture of me, you'll win a funny prize. So if I'm up here gesturing around or something like that and you get a great picture, tweet it, you'll win a prize. So, what are we going to talk about today? Aside from advanced Apex testing, we're going to talk about these specific parts of advanced Apex testing. First one we're going to deal with is annotations. At test setup, at test visible. Is anybody using these? Okay, so most people here are using them. A lot of the times, I put this in my advanced presentation because a lot of times people don't know what they are, or they've seen them, but they don't really understand what they're doing with them. Or they've seen them, but they're not personally using them. So we're going to talk about them real quick. We're going to talk about using CSVs for loading data. Is anybody doing this one? We got one person. Okay, great. This is a really powerful trick, really powerful tip. You're going to be able to load CSVs directly in with one line of code, and you'll also load them into your database as well. So you'll get them in memory, you'll get them in your database, all one line of code. Winner, winner, chicken dinner. We're going to talk about asserting your sanity. This is where you get to stand up and say, I am not crazy. And everyone will believe you. Right? We're also going to talk about mocking things. Is anybody doing mocks? Got a couple people in here. If you've played with a mock, but you're not really comfortable with them, I'm getting the lay of the land here, okay? We're going to talk about stubbing things. That's related to mocking if you're doing stubs. Okay? We're going to talk about why DML is evil. This is a very charged event, a very charged statement, but I believe DML can be evil. And at the very end, we're going to have some Q&A time. I like to float around, so if you're trying to raise your hand or ask a question and I can't see you, it's probably because I'm standing right here and the projector is right in my eyes, so feel free to yell out, okay? Also, since we're live casting these, if you ask me a question, I'm going to repeat it back to you, not just to make sure I understand, but so the people at home can also understand as well. All right? So with that said, let's jump into the one that everyone seems pretty familiar with. Oh, wait. I got a new slide in here. What do we want from our unit tests? This is my personal list. Some people want quick unit tests. Some people want exhaustive unit tests. This is my list. I want them to be fast, which means I don't want to wait for them to run very long. I want them to be lickety-split. I want them to be easily understood, so I don't want a lot of magic in my unit tests. I want somebody who's new to the team to come in and be able to sit down, read my unit test, and understand both what the test is doing and what the code it's testing is supposed to be doing. Make sense? One of my favorite tricks for onboarding new employees is to give them just the unit tests of an org. What are we doing here? Read through the unit tests. It does a couple of things. One, it makes sure they actually read the unit tests. And two, it gives you an idea of how well your unit tests are actually covering your org's code. We're going to look at why we want them to be repeatable. Why would you want a repeatable unit test? Anybody? I want a repeatable unit test because the one that's not repeatable means that something is working some of the time, but not all of the time. And I want my unit tests to either fail all the time or pass all the time. And what I mean by all the time, I'm going to run my unit tests 10 times in a row, and they should all pass 10 times in a row, or fail 10 times in a row. Okay? We're going to look at descriptive unit tests. This is a big one. A lot of people are like, what? It's unit test 1. No, you got to have descriptive unit tests. You got to be able to describe what they're doing and why in your unit tests. And finally, we're going to talk about definitive unit tests. And this boils down to one thing being, you should only do one thing in your unit test. It should define one behavior that you're testing, right? We'll look at that one a little bit more. So as we dive in, let's look at test setup and test visible and see how these help. This is what that looks like. Can everyone read the code in the back? When I first put this code presentation together, I was like, oh, I like that theme. And then I saw it on a 30-foot projector, and I'm like, oh, I can't read that theme. I apologize. But here we go. We've got at test setup, at test visible, or excuse me, at test visible here. And we've got it once on a private integer variable and then once on a private method. Now, do you use private methods in your classes? A few people, okay. Do you use private variables? All right, before test visible came out, a lot of people would raise their hand and be like, no, because I can't test them. Well, the way you test these is you mark them at test visible, and when you do that, in a test context, all of your private annotated test visible methods and variables are visible to the test execution. So what that looks like here is we've got a test, we've descriptively named it test, right? Eat my own dog food here. We've got this thing here, and we're going to pull up our variable record number, and we're going to assert that it equals what we think it should equal. And that, if we go back, you'll see that this was our record number was private. But we're not having to do anything special once we've marked it as test visible. It's suddenly visible as if it were public to our test, and only the test. If you tried to access that in an actual production run, it would fail. Everyone with me on test visible? Does that seem like a useful thing? This is one of my go-to things when I'm looking to hire someone. I look through their tests. I ask for an example test for a very specific thing, dealing with price books. I say, hey, write me some code with price books, and then give me an example of it and show me the tests for it. And I want to see if they're using test visible. I want to see if they're using a lot of these tips and tricks. It gives me an idea of whether or not they're new to the platform or if they have a lot of experience and where that experience came in terms of what API levels they started dealing with. I've been working on the platform since API 11. I think are we on 44 or 45? We're on 44, right? Yeah, 44. So I like to think I've been around the block a few times. When I started, I had hair. This one came out only about 15 releases ago, test visible, test setup. So that one's fairly new. Let's talk about CSVs. You raised your hand earlier and told me if you're using CSVs. What does it mean to use a CSV? Well, to use a CSV, you're going to be using test data. Test data is important. Test data makes the tests important. They make them matter. You can say something is true or false in a test, but whether or not it's actually true based on your data is what actually makes or breaks the test. So when we create most unit tests, we're going in and creating data. In this case, we might need an account. So we're going to create an account, and we're going to insert it. Fairly basic, boring, 2 lines of code, pretty easy. That can get unwieldy when you need an account to contact, 4 opportunities, each with 3 opportunity products, a revenue schedule, and everything else in order to test whether or not your billing system works, right? So what you do is you start to put things in to a CSV file. Now in this case, we've got some accounts. We've got 3 of them. Each one of them is going to have the name, the website, phone number, etc. And you're going to save this CSV file, and you're going to upload it as a static resource. You can call it whatever you want. Call it account-data.csv. Once you've got your account data CSV in place, you can then turn around and call this test.loadData method. And this is where all the magic happens. And you see what we're doing here is we're going to give it a type, in this case account, and we're going to give it the resource name that we gave it. So account-data.csv. Okay. Now, when we do this, we're going to load this data, and it's going to go into 2 places at once. It's going to go directly into the database, so you can query it later, and it's also going to show up in the list you assign it to. This part's optional. You can just drop it in the database. Does anyone see the power in this? Now, the next step on this, the next level is when you say, hey, business users, I want you to own the CSV of account data. We'll make sure that we manage the change management of putting that CSV data in place, but I want you to come up with the websites, the account names, so on and so forth. Why does that become powerful? Because as soon as you have to write a unit test for regression made on McGregor or a name that has an apostrophe in it, then you realize that you don't want to be trying to come up with every variation of every name and every encoding that somebody might have legitimately that you're not covering in your tests. Being able to write a test that uses all of these in the CSV and iterate over those becomes really powerful. Now, that seems pretty basic, and it is pretty basic, but what you can do, and what becomes even more powerful, is that you can load multiple CSV files. So in this case, we've got our account one we just saw. We've got some contacts, because accounts have contacts, and we've got opportunities, because accounts hopefully have opportunities, right? That was the softball question. Okay, so we're going to load these opportunities. How do we tie them together? This is the super secret magic sauce. And the way you do that is by providing completely made up but consistent IDs. Ever since about the same time we got the test visible and test setup annotations, we had the ability to start providing in-memory IDs to S objects. Now, as soon as you try and insert that S object, you'll get an error because you cannot insert an ID. But you can specify them on your own as long as they're in memory. So we're going to make use of this trick by writing CSVs that provide an ID, 1, 2, 3, first for accounts, and then for contacts. Now in this case, we're going to provide an ID and an account ID. And so long as the account ID in this column matches something that you've already loaded from a CSV, that relationship is established in the database automatically. Or as I like to say, automagically. Okay? Now, you can keep going on the chain down the chain like this. We can move that from our contacts to now we've got our opportunities in here. And keep moving further and further down the chain. You can actually, with 3 lines of code, insert 3 objects all related to one another and start testing from there. Really powerful stuff, especially if you don't have to maintain any of those CSVs. Here's the mind-blowing part of this. I want you to look at this bit of code here. It's a for loop over an account. That's pretty boring, pretty basic. But what becomes really powerful is if this is where your test code lies, then every account you have in your database becomes an entry in something that is being tested. This makes adding data for regression tests that much simpler because all you have to do is add 1 line to your CSV. I'm seeing lots of like faces out here. Somebody want to talk to me about how you're feeling about this? No? Nobody's feeling this at all? Is this something you feel like you might turn around and use this week? Yeah? I really enjoy using CSVs for that. Let's talk about how we can make our unit tests better for us. We can write unit tests till we're blue in the face, but sooner or later one of them is going to start failing intermittently or failing when it was passing, and then we have to go in and figure out what changed. Part of the work of finding out what changed is figuring out what you can or cannot trust in your tests. Can you trust your data? Is your data safe? Can you trust your test setup? Does your test setup make sense? And here's where certain assertions can make a lot of sense. So if we look here at this test, we're going to create some data, and then we're going to assert that that data exists. Right? All I'm doing in this one with this assert is making sure that I actually have data in the database. What does that buy me? When this starts failing at 3 in the morning and I go to read the tests, I know that I have data in the database here. Okay? I don't have to worry about whether or not I actually got data in for something else, or if I'm getting the one that bit me on this one was we just turned on duplicate rules, and suddenly you couldn't insert the same contact, and we had tests running in parallel. So every once in a while, not all the time, but every once in a while, our 2 contact tests would run simultaneously, and I would get Homer Simpson twice. The second one would fail. Okay? Putting an assertion in here saying, I know that I have data here, allows me to immediately move on to the actual logic of what's being tested. Pretty simple, huge time saver. Another one of those things that I look for when I'm evaluating unit tests, like how long has somebody been doing this? Have they been working on this 6 weeks, 6 years, etc.? let's talk about a little bit about mocking. The concept of a mock is that you're going to take a real object and replace it with a fake one. And if that seems like a bit of hand waving, it is, but it's really useful. When you're using a mock, you're testing something other than the mocked object. Okay? So the example of this, sort of canonical example of this, is making an HTTP callout. Has anybody written code that makes an HTTP callout? It's fairly common stuff, right? So when you make an HTTP callout, what can you not do in a test? Make the actual callout. So there are a couple ways of handling that. It used to be that you would write a if is test running block, then do something here, right? Which doesn't really help you with things other than get around the test coverage requirement. When you write a mock, you're going to be able to create that mock and then insert that as the mock for the callout. So when your code makes the callout, your mock object is the thing that responds, right? And so we're going to look at a few variations on that, but the first one is this mock factory. So when you have a mock factory, that mock factory can create a mock object for you, and it can have all sorts of information in it. Here's one way to do it. You can have this interface implemented called HTTP callout mock. And to do that, you're going to have to fill out this response object. The response method. The response method always takes a request, and you can do whatever you want with that request, but you still have to return a response object. So what I like to do is provide a mock factory that has the respond method here, but it also has a constructor. And now I can construct a mock that matches my test's needs on the fly. So here's give me a mock factory, and I'm going to insert the code, the status, the response body I'm expecting back, and any sort of headers that I'm expecting back as well. Okay? This becomes really powerful because I can write a unit test that says, show me a failure object, and that can be very similar to show me a success object. Okay? All I'm doing is changing this mock. Now what that allows me to do is I can write several unit tests very quickly at the same time. If we could set more than one mock per execution, then I could write one unit test that cycled over success and failure options at the same time, or in sequentially. Does that make sense? Okay. Now, there are other ways to do this. This one is a little bit more complicated, but this one takes a list of responses that you expect back and then provides them in sequence. This is really powerful because oftentimes when you make one HTTP callout request, you have to make several. Maybe that's to authenticate, maybe that's to get one bit of data from a REST API, take that information, mutate it, and then get the next bit of data from that same API. This allows you to create a list of responses, knowing that every time the mock is called by your unit test, it'll automatically respond with the next response in order. Pretty cool, right? Now the best part about using a mock factory like this is you can have one mock factory in your entire code base, and then each of your tests can create the mocks it needs to move along, so you're not littering your code base with hundreds of mock callout for talking to REST API, Amazon Web Services #1, etc. You have one bit of code in here. You can add things to it, construct it as needed. Now I want to point out a little trick here. At the top, I am calling this @isTest. And that means that this class can only be used in a test context, which means that none of this counts against my code coverage. So if I have a huge and well-defined mock factory that can give me a callout mock for anything I need, none of that's counting against my code coverage, and makes my tests a whole lot simpler to read too, because I'm not duplicating all of this. Everyone with me? Okay. So stubs. We've talked a little bit about mocks. We talked about how HTTP mock callouts are the place that you canonically use them. Stubs are a little bit more complicated, but they're infinitely more powerful. It's like adding the 5th infinity stone to the gauntlet. You've got 4 of them, you're really powerful, you're up to snuff, and as soon as you add the 5th one, the world is your oyster. You can do whatever you want. Okay? So let's look about what that means. The idea of using a stub is to conditionally inject a mock. We already talked about what a mock is. It's a fake object. We're going to conditionally insert a mock of a method. Okay, not an object, a method. And often this is referred to as stubbing a method. We're going to do this to just about any method call. Now there are some caveats. Those are listed on the right side there. You can't do static methods because of how stubs work. We'll get into that in just a second. You can't do classes with only private constructors, again, because of how they work. Properties, triggers, inner classes, system types, and batchable classes. Okay, and that seems like an awful lot, but when was the last time you really needed a fake integer? Right? When was the last time you really needed a fake trigger? Right? The list here is long, but they're actually not very common to actually need to mock or stub these. And like we did with the mock, we're going to have one stub provider that can do multiple different stubs. However, that stub provider has to be a one-to-one per class. So if you think about it, if you're in the habit of creating a class for whatever you need, and also a test for that same class at the same time, you can also create a stub provider for that same class when you create everything, and then you're ready to go. Okay? So how these work is that your stub provider class is going to implement this interface, the system.stubProvider interface. We're very creative with our naming at Salesforce. So system.stubProvider is what you're going to implement. And to do that, you have to have one method, and that method is the handle method call. Again, creative naming. And that handle method call has a whole slew of parameters that you can pass in. And those parameters happen to be things like the object that you're stubbing, what the method name being stubbed is, the return type, the list of parameter types, the list of actual parameters being passed in, and then finally a list of arguments for the stub. Now, that's an awful lot of power. Let's break down what that means. So you can take and then turn around and use our new switch statement. I love our new switch statement. Use this new switch statement along with the stub method name and have one handle method call in your stub provider that can handle any method in your actual class. Now they have to be one-to-one to the class, so you have to have an account class and an account stub provider class, but that stub provider class's method can handle a number of methods in your account class. Okay? So we're going to switch on the method name. When the method is awesome method 1, we're going to return a string, yay, called awesome method 1. We're going to have another one, add two numbers. We're going to return 4. It's an integer, right? But here's where we get really interesting. We're going to look at the polytype method name. So we're going to say if our method name is polytype method name and our return type is Boolean, then we're calling this one particular method that has a type of Boolean response. This is useful if you've got object or methods that return more than one type of object response. Okay, and we can do we can switch or conditionally change our response based on any of the information being passed in here. So how do we actually invoke the stub provider? So let's look at an example here. And the stub providers can be a little confusing because you have to use what's called dependency injection. And that's the core of how they work. So we're going to have a little side conversation on dependency injection, and then we're going to show the example of how stub providers work. So here we have a basic class date formatter, and you'll see that we've got a date helper object that we're passing into our method, and we're going to use that helper object to grab today's date. Okay? So think of date helper as sort of a wrapper on the date class. Okay? And now instead of figuring out today's date, etc., formatting it, here we have this get today's date method. So we want to test this. What about this are we going to test? This is the interactive portion. What part of this can we test? I'm sorry, what? Yeah, we can test the output. We can say, what is today's date? And we can assert against today's date. But more importantly, we can assert against the format of get today's date, what that output is. We know that it's going to be a string, so we're not looking at a date object. So now we can start to formulate how we can write a test about this. And it'd be pretty simple, just a system assert get formatted string equals this string. However, sometime in the future, somebody's going to go in and change the implementation of get today's date. Do we care about the implementation of get today's date in this test? No. And that's our candidate for stubbing it. When it's used third-party code to what we're testing, and we don't care about how it functions, we stub it. Okay? So what that looks like is our date helper class, get today's date, return date.format. Pretty simple. Now, In order to use this in code, we would create a new date formatter. We'd create a new date helper. And we'd call our date formatter with the date helper method. This is called dependency injection. We're going to take our dependency we need for this method, and we're going to pass it in from another object. And here becomes the way we can actually start mocking things. In this in this stub provider, we're going to take our handle method call, and we're going to say, if the stubbed method name equals get today's date, we're going to return hello Dreamforce. Now notice it's not a date. It can be anything we want, because we know that this method is supposed to return a string. Okay? So here's our test for that. We're going to create a date helper that is a mock, and we call this create stub method. And this create stub method takes two things. One, it takes the class that we're initially stubbing, the date helper class, and our actual mock instance. So we had that mock before. This is what we're going to insert here. And now we're going to get this mock DH object. And when we call our code, get formatted date, we're going to pass in our mock date helper instead of an actual date helper. Now, whenever this method, any method in here is called, mock date helper is called, it's going to automatically return hello Dreamforce. Okay? That's the power of stubs. They allow you to create a response that is whatever you need for your test without having to worry about what is actually backing the implementation of that method. And become really powerful for two reasons. One, when you're creating a stubbed object and running the stubbed methods, that's a whole lot faster than going out and grabbing data from the database and whatever your real implementation does. So your tests run faster. And two, it makes the implementation of things you don't care about something you don't have to worry about. Okay? So if you've got an implementation here of get formatted date and you don't care how it's working, that's fine. That's not your domain. That's not part of what your team is working on. You can mock it. You can stub it, and you never have to worry about the team actually caring about it, changing it underneath you and breaking all of your tests. Now, if they change the way it works in terms of parameters required, etc., your tests are still going to break, but they should really be communicating with you about that anyway, right? So that's how you stub those things out. Okay. Does anybody see a use for stubbed objects? This is the one I really want to sell. I love these things. So when you go home, like later today or next week, I really want you to be like, I can stub that. I know how to do that now. This is the golden rule for stubs. If the code you're testing, if the code being tested uses an injected object, it is not only a candidate for that injected object being stubbed, but you should stub it. Okay? That's the way you write bulletproof unit tests. And it's actually technically the only way to write a unit test on Salesforce. Everything else is technically an integration test. Okay? The favorite one, DML is evil. If you think DML is evil, give me a hand raise. We've got 4 people. Okay. All right, this will be a hard sell. What do I mean by DML is evil? The slowest part of any application is data I/O. It used to be that things were on revolving media, and that was really slow, and now we have flash disks, and those are faster. But still, if you have to go get data and put it in your database and then query that data out, there's a whole lot of work in there that you don't actually need to do if you can get away with it just to test out your logic. Imagine if you had to do 2 + 2 = 4 as a unit test, but in order to do that, you had to go put 2 in a database and then query 2 out of the database and then do it again for the other side just to get your answer. It seems a little ridiculous. We have tests like this, or create data like this, that we can give us this sort of output here. And if we don't actually need to create in the database, we don't have to, because we can, for a few releases now, create an ID, set the ID of an object in memory. Which means if I need to create an account but still have a reference to it for another object, I can create one, give it an ID, and move on with my life instead of inserting it and then querying it. So ask yourself these questions. Am I testing any DML-related code? And if the answer is, I'm testing a trigger, then the answer is probably yes. You're going to have to do DML. Are you doing things with testing an interaction between workflow rules or process builder and your code? Yes, you're probably going to have to do some DML. On the other hand, if you're not doing DML, and most of the time I wager we're not, you don't necessarily need to do DML unless you find that there's some edge case where you need some data that is being modified by a trigger in flight, and you'll find those pretty easily if you have them. The question then becomes, how can we write a test that we don't have to do that? And the two things in our favor are, one, we can create IDs in memory, and two, we can stub or mock different objects. With those two in mind, we can look at things like this. And this is how we sort of make it happen. We've got our test factory, and our test factory is another thing that I'm pretty sure everyone's familiar with to create objects that we might need. So in this case, you've got an account. Now, I like to write mine just with a little bit of tweak. So instead of get account, I can get account, and it'll return the account pretty easily down here. But if I'm also passing in a Boolean, then it'll insert it. Okay? So I can still use my same test factory methods. I can still grab things from a CSV if I'd like. And I don't necessarily have to insert them unless I really need it. Making this sort of tweak, this very small tweak to your test factory, can start to give you a really quick idea of whether or not you actually need to do DML for your tests. Because you can get an account, you can get a contact, you don't have to put those in the database in order to use them. Okay? So take some time, make this tweak to whatever you call your test factory, and then you can start running your tests as they are. And without that do insert equals true, see what happens. Do all of your tests still pass? Well, that's interesting. I've been doing DML for years and didn't need to. Right? Imagine going to your boss saying, hey, I just shaved our unit test runtime down from 28 minutes to 13. Can I have a bonus? All right. That was the end of my prepared remarks. I wanted to make sure we had lots of time for Q&A because the last time I brought up stubbing and mocking, I had literally an overflow of questions. But also last time I talked about it, nobody knew what a test setup and test visible annotation was. So questions, answers. If you don't ask questions, I'll ask you some.
The CSV import,
Mm-hmm.
I don't use that purely because how it's managed. The static resources seems like a wrong place for it. It seems like it could get muddled up. So, for example, if you've got an account CSV, it could get lost in the amount of static resources you've got in there. But not only that, if I've written a test that uses it, and then someone else comes along and says, oh, that's good, there's an account CSV, I'll just add another account to it because I need an extra account. It could break a lot more tests if they're written in a particular way.
Yeah, so his question was based on a comment, so I'm going to repeat your comment, which is managing static resources for CSV data seems like things could get lost in the list of static resources. And because of that, and also because somebody might go like, oh, I'll just use these, but I need a special test case here. That's a governance question in my mind. And those are the hardest ones to answer because everyone likes a technical question where you can just button it up with some code and move on with life. The governance question to me reads like this. If you've got a CSV of 20, 25 accounts, and you need something outside of that, it has to go through change management or be written into your specific test. Okay? And I'm not one of those people who says, just because we're loading things from CSV doesn't mean you can't ever insert something specific to you or your test into the database as part of your test. I'm not that dogmatic about it. It's there to make your life easier, to make the test easier to read, for people to figure out what's going on, and to make them repeatable, not because we're only gonna do it this way. That said, if somebody comes across a use case for having another account in that testing accounts, they probably have a good reason for it. There's no reason why they can't put that into change management and refactor it later to pull from the CSV. As far as the comment about managing them through static resources, I hear you. I don't know what would be better. If you've got feedback on that, I'm happy to take it back to our product teams. But I know that static resources are a handy-dandy way of doing it. They can get lost in there. Naming conventions can also help, now that I think about it. So all of our test data I work with a nonprofit, and so all of the test data in the nonprofit that comes in through a CSV, all of those start with test data underscore. And so it's pretty easy to filter by T and figure out the ones I'm looking for. But that's a great observation. And again, if you have feedback on it, I'd love to take it back to our product teams. Other questions, comments, Snyder marks?
You mentioned that you had problems because tests were running parallel, and so they were in the same execution context in some way. What is the time frame where the test context resets? Is one test context, or where does the context reset?
That's when does the test context reset is a great question, and it largely has to do with how you've written your tests. If you write them properly and up to date, and you've got them saved under a relatively recent API version number when you run them, they're going to run just fine in parallel. It's the really old ones that can have issues. And your actual specific question is, when does that test context reset? And the answer to that one is, unfortunately, I don't know off the top of my head. I will say that I most often run into situations where it's an issue in ancient test classes where I have lots of test methods in the same class. I don't have a specific answer to your question, though, unfortunately. If you remind me of the question on Twitter, I can actually go pester the person who does know, and we can, make that well known. Other questions, comments, Snyder marks? Okay, I was anticipating some more questions. Oh, there we go.
Have you looked at Apex Mocks that is now using the Stubbing?
Apex box.
Apex Mocks.
Oh, Apex
from
mocks.
Financial Force
the
library.
Financial Force library.
Yeah.
Yes.
Is it a good implementation? So that's a bit.
Is it a good implementation?
Because it seems like you were explaining essentially how to write your own mocking.
Yeah. So
Suite.
the people who designed the Stub API happen to also have been highly influential in the design of the Apex Mocks library. I don't think they solve the same problem. They solve very similar problem sets. I prefer the generic Stubbing interface because it's more flexible, in my opinion. Apex Mocks makes certain assumptions about the way you are writing your code, and you code to an interface. There's always an interface above every class, and those are good and wholesome assumptions, but they're not always true, right? When I jumped into the org and started working with a nonprofit, none of those things were true, not a single one of them. And I can't, as the only volunteer writing code, suddenly reverse 7 years of architectural decisions. So I find that if you have a green field, if you're going to adopt enterprise architecture patterns, service layers, etc., from the get-go, or you get the opportunity to do a reorg and you can start making those decisions, yes. Otherwise, go for the individual mocks that you can create yourself. There's more work involved, but it's also easier to adopt mid-path. But to answer your specific question, I think it's well-coded, yes. Other questions, comments, Snyder marks? No one has taken me up on the Snyder mark yet. Okay. Do you have other Apex testing tips that you would like to share, you thought I might mention that didn't?
What are your strategies for code coverage? So do you try and get 100% or how close to 100% to write test classes for? Because you sort of keep going.
Yeah, so the question he raised is, what's my strategy for code coverage? Do I care about getting 100%? What do I think matters? And so on and so forth. You're not going to like my answer here either, because it's not a cut and dry do this. What I like to do is I think that all code should be reviewed by other human beings, and that as part of your code review team, your team should come to a consensus as to whether or not there is enough code coverage. That said, I like to say that you should have positive, negative, user, and permissions-based testing for everything you write code for, which in the process of writing those 4 styles of tests, you're going to get way up there anyway. But if it comes down to, I've got 89% and I could write 400 lines of tests to get the other 11%, or we can just say 89% is enough here, I think that's a decision for your team. Be like, yeah, we don't think the risk of this untested code, because it's usually like 1 line here, 300 lines down, there's another line, so forth. You know, getting those few lines of code, does the risk involved in not testing those make sense? And oftentimes I think that the team as a whole can work together, fight over it, and they can get passionate fights. But at the end of it, they're going to be like, yeah, this is fine, or no, we need to test this one, or this, you know, this is not enough as it is. As a general rule, think that always arguing and fighting for 100% test coverage is detrimental to your team's health, because at the end of the day, I personally like to solve hard problems, and testing is only part of those hard problems. And I would rather sit down and, you know, work on a new machine learning algorithm to determine fraudulent bank transactions in Salesforce than writing unit tests for a contact trigger, right? And as a team member, I know that I still have to write my unit tests, and I'm passionate about unit testing, of course, but I would still rather work on something new and cool. And so there's the whole like trade-off thing, morale of your team. Nope, no, oh, he's just scratching his head. Sorry. I was really excited there. I was like, oh yeah, another one. All right, other ones, because otherwise we can just have a few minutes left to go steal cupcakes.
So written test code for a long time. Never even into stubbing, really.
Mm-hmm.
Most tests that we write are based on triggers.
Mm-hmm.
From what I hear so far, you can't really stub too much of that because the trigger works. It works essentially with all sorts of other stuff. Is a piece of advice is for me to go back to some of that test code and just try to stub one to see how it works. And if it doesn't, let it go. Or does it need more analysis? I mean, I'm trying to figure out how I get from what I always do every day to how I can possibly stop a test run that's taking 40 minutes right on an org,
Mm-hmm.
and would let down because most test code is running triggers.
Yeah, so let's take a crawl, walk, run approach here, right? The first thing to do would be to write a stub to make sure you understand the mechanics and the theory of how they work. And you can probably do that over lunch, right? The next step, I would say, would be to take a particular test and try to figure out what it would mean to stub out the logic there from your unit test. And maybe that's not a trigger-based unit test, okay? Now, the sort of like run with it approach, you're probably going to end up re-architecting things a little bit, because if you have logic and code directly in your triggers, you can't stub it. But if your logic is in a separate class that is called by that trigger, you can stub the heck out of that. You can do all sorts of things here. And the payoff there is, if you want to test one section of a trigger, you can stub everything else out except for that one section of your trigger.
Because that's the missing testing.
Mm-hmm.
But you have to assume that the other methods are not impacting on it.
Well, you've got tests for those methods too, right?
You do.
Right.
But you're kind of testing everything in unit break. The one thing I'm trying to get to is limit testing. Like if I've got 15 methods off a trigger in a helper class,
Yep.
and I'm stubbing out some of them, that's not really testing my limits.
Right.
There's just one method for that.
That is not the use case for stubs. Okay. The use case for stubs is testing things in isolation to make a true unit test, where you don't care how other things are working. So if you want to test one segment of a trigger, you would stub everything else out. But you would have to do it in your handler class. Okay. And then you would unfortunately still have to cause DML to fire that would invoke that, and then everything that would be mocked out, and then for your one little section. The upside to that is you're actually going to have much faster executing tests for the logic in your tests. If you're worried about hitting limits, then you're going to have to go through all of the work and all of the time to hit those limits, regardless of how they come about, whether it's CPU time or database inserts, etc.
Maybe just one add to unit tests. Try with long strings if you have anywhere the user input. Try with strings over 10,000 characters or over 50,000, because then you're easily hitting limits of the engine for regex.
Hmm.
Regex engine doesn't work really well with long strings. Maybe you need to replace code will fail in moments where you don't expect it, because maybe the record with the 50,000 characters go through, but then your execution time is so high that you don't get the next 10 object through. So this is the point which you can't see what's happening, and you get an error of the underlying platform, so it destroys your logs and you don't see any helpful logs of this.
Yep. So you raise a great point. Let me repeat it back so that my mom at home can hear. You also need to be testing unintentionally vague limits. What I mean by an unintentionally vague limit, you point out regexes have a very high execution time for fields of information to search against more than 10,000 characters. Well, if you want to try and do a regex against something like a user input from a text area, you may end up with 5 times that amount of data, and then you're in a whole world of trouble because you'll hit a CPU timeout, not a data timeout, not a data limit. It's a great point, one we don't often think of. This is what I refer to as Cinderella test. Cinderella, as you know, was beautiful, and she was beautiful all the time, but she had the beautiful dress and the whole thing, and then at midnight her carriage turned back into a pumpkin. So something hit, some limit passed, and then it all failed. Okay, so a Cinderella test is one of those where it works great until your user puts in 50,000 characters of information. Where does that come up? Well, when somebody's imported a Word file into a text area, or they've copied and pasted a web page in there, and then all of a sudden you're looking for keywords to link it or something like that, and it blows up. Your unit test probably works just fine because you've got a paragraph of text with the keyword being the third word, right? Tips, tricks, frustrations, snide remarks, questions? All right, well, I'll give everybody 10 minutes back. Thank you very much for coming.